So this is just an informal training, not to be used for other training as a technical training or anything like that. This is more for informal training for your information on what the labels are and how to interpret it, okay? So Schneider Electric did a short circuit coordination arc flash study for the facility here. So this is a brand new facility. And so why they need to know about arc flash? Electrical accidents is sixth among all causes of work-related death in the U.S. No more than 300 fatalities and 4,000 serious injury annually related to electrical work. So what kind of danger? You got shock, electrocution from inadvertent contact with energized parts. It's long been recognized. Before we had any kind of law and safety requirement, electricians would go there to test for live, use their finger. We don't do that anymore. We recognize that that's dangerous and could kill you. Okay. So what is arc flash? Arc flash associated with the release of a lot of energy through the air, and not every arc flash is considered dangerous. I know, like when you arc welding, that's control. There's an arc, but it's under control. The arc that we're talking about here is accidental, inadvertent, that wasn't expected. It could be from equipment failure, or it could be from a worker or personnel accidentally dropping something, right? And during an arc flash, you got significant heat, a lot of pressures and concussions that can knock you from unexpectedly and rupture eardrums and spew molten metals, coppers and all that stuff. So you got to make sure you're prepared for that. And okay, and NFP 70E kind of provides some workplace safety and some guidance if you don't have an electric work program at your facility. So there's a reference for that. And there's some requirement here that talks about arc flash requirement. So the first things we usually do, we always do to get these labeled here is we need to develop a system model of the electrical system. Since this is a brand new facility, a consultant designed it, had a one line developed, called out, cable size and breakers. So we gather all that information and we put it into a model, and we calculate the short circuit coordinations and arc flash. So basically, the short circuit determines the fault current level at each switchgear panel board, and then from there we'll do the coordinations. You want to, if there's a fault downstream, you don't want the main breaker to trip. You want a breaker or something as close as possible. You want to isolate it. You don't want the whole facility shut down. You don't want a 20 amp breaker tripping the main breaker, taking out the whole school. So the short coordination study does that to the best, right? And then, but you also got to consider arc flash. Arc flash incident energy is determined by time and current, available fault current. So if you set your coordination too high, your available fault current, your incident energy might be a little too high. So you have coordinations, but your incident energy might be really high. So there's a little of a balance there, a little bit of an art. You can't just set everything high and or coordinate, and you got to consider the human element side to it. So once we do that, this, I don't know if you guys have seen the report, but in the report you'll see the short circuit current value, and we calculate based on what you have, the available fault current and the equipment that's in each one of the panel. A lot of data to analyze. So short circuit, and then you got, then we'll analyze, see if that available fault current is greater or less than the equipment itself. So you want equipment to be rated a little bit higher than the available fault current. Otherwise, if there's a fault, it can't contain the available fault current, so the possibility it could explode. I haven't seen it, but test proves it, right? That's why we have this, and that's why we do this.
The table he just looked at, that's going to be a short circuit coordination study.
Yep.
So eventually, when you get your own amps, you will have the operating procedures for the switchboard, but you also have the full study. Those are the tables that you need to reference in order to figure, and also need to know also the labels. We'll go over that in a second, but I just want to reference that when you get that, you'll get those tables.
Yeah, and
specific to this location.
yeah, and if you have, let's say you have some, you want it out of circuit, and an electrician comes in and it's like, okay, he just randomly pick a breaker that just will fit in there. You can give him this information here, the available fault current for that panel, and make sure he gets a breaker that's rated higher than the available fault current, or select one that is similar to the one that's in there already. Otherwise, the rating of that panel now is rated with the, according to the lowest. So if he put in a lower value, if that panel board is rated for 35K and he decides it's cheaper, let's go with the 18K, circuit breakers, it's cheaper. He puts in there, now that panel is rated only 18K, so that whole panel is it's underrated.
And what that means, if a device is underrated, in case there's a short circuit, that device can actually blow up.
Yeah.
Because it cannot handle that whole pressure. So that's why it's rating the devices it's really important in the future if you add loads. Yep. But if you're adding panels, those kinds of things, anytime things are happening, that study will have to be revised.
Yeah, if you're adding any additional stuff, if you're putting a generator or adding any big loads or that can contribute to the changing the available fault current, we really need to analyze the system to really be, meet code. Of course, this is where I was talking about, coordination studies. So each one of these breakers has their own characteristic, how they operate and respond to current. So as you can see here, this, like this one here, this is fixed. Like this right here, the one on the far right, that's like maybe the main breaker. See right here, it's kind of a little bit overlap, so maybe we move it a little bit to the right to get some coordination if there's a fault in here. Ideally, you want as, if you had a fault here, you want this one to trip instead of this one. So there's some overlap here, but, right? So that's why we do the modeling, do the study, analyze all this data here. Then, of course, this is as found and recommended. So there's we do studies for existing systems. So we'll analyze existing systems and see what the available fault current and what the arc flash incident energy is for the as found, and we can make recommendations. But for this, it's a new construction, so we'll make the recommendations. Make sure you set these equipment long time, short time pickup according to the study. Otherwise, these values are invalid. Okay, so it's like you got long time, short time pickup on all these right here. You got to make sure that it matches the study. Hopefully somebody came out here and, and dialed in, right?
So I'm assuming they had Taurus do the startup, so I'm assuming that's
okay.
Did all the settings. I'm assuming, because I see the breakers pretty much
set. Okay. Then if you look through the study, you'll see all this information. Right? And then we'll get to the label. So here's. I
take that back. Some of these are minimum, so. Okay.
Yeah, and if you look at this and you see them all at minimum, because it comes from the factory all at minimum, and you have to adjust it according to the study.
Oh, gotcha. These have been adjusted then. These are all about a quarter of the way.
Okay.
Yeah, these are all different, so these have been adjusted.
So yeah, so you look, when you get that study, all this right here, you have this panel, this switchboard here's name. Then you'll have a feeder that lists this right here, panel HA2 or panel ATSEE2. And I'll have this breaker information here, and they'll have settings for that particular breaker. So you got to make sure that breaker setting right there matches whatever's in the report, right?
And okay. Also one thing to add to the settings, since we're looking at it, very important. The first setting is a long time pickup. If it's not set correctly, that could be cause of nuisance trip. I say nuisance trip because, for instance, like this one right here, this is a 400 amp breaker, right? That I'm actually set at 200, but that's like a 200 amp breaker right now. Now, if that's what the coordination study calls for, then it's correct, but if not, that's a 200 amp breaker, not a 400 amp breaker.
Oh, wow.
So this is where the settings really have to match or come into play, because otherwise, if you, this breaker is at 400 amps, is rated to, it's rated for 80% of the current, so you can definitely put more than 200 amps, but if you put more than 200 amps, you'll trip the breaker. And you wouldn't know why, you'll say it's a faulty breaker, when in fact, those settings really, really are very important. The rest of it, short time instantaneous it's a different, but that's long time is one of the most important settings.
Same breaker, different settings, or having
Yes.
different values.
Different situations,
Yes,
different
yes.
settings.
And usually
Kind
we-
of study.
Yeah, exactly.
Yeah,
Yeah.
and when you look at the breakers, this feeds a panel downstream. Those may or may not have breakers, but usually when you set and you coordinate between this breaker and those breakers, in case of a fault, you want to get that breaker to trip first before it gets over here.
Oh, gotcha.
So that's why those settings are really, really important, that they match and they're set correctly. Otherwise, you could have some,
That's the
Challenges.
coordination portion of the study.
when you
Well-
turn all the lights on, all the building on, all the loads on, if they're not set correctly, you could have issues. And been there before.
Yeah. Okay, so we'll get to the arc flash label here. So once we do all that study, analyze all the informations, and we agree on what the setting is and what it should be, and once you set all that, we get a label. We develop this label here, and here's that label. So this is the energy at 1 feet 6 inch, 18 inches. That's the standard, for most people. So some people be longer, some people be shorter. So this is the average, and this is the standard calculations based on 18 inches. So if you're 18 inches away from an exposed conductor, exposed live parts, that is the available fault current, 77 calorie per centimeter square. Now, they also give you another one, the arc flash boundary, that's 11 feet 7 inches. At 11 feet 7 inches, that you can be exposed to first degree burn. So the calculation there is first degree burn is 1.2 calories per centimeter square. So you need, at 11 feet 7 inches, you can be exposed to that. But when we did the calculation, it's like a spherical. We don't take account in a room and all that, because
And that's an open air with no
open
safety
air,
equipment on, right?
yeah.
Now, I think what that label will tell you, that you're not supposed to operate that switchboard even with safety equipment on, because the arc flash is much higher, right? That's why it says prohibited.
Oh, so that's what the prohibited for, right?
Yeah.
You're 70 cal, right? So 77 cal, which is very high.
And the other portion of the list is 480. That's the nominal voltage. And then the limited and restricted approach, those are fixed. It's based on the voltage level. So you got your limit and your restricted approach. And this here will give you the definition of what a limited approach and a restricted approach and arc flash boundary is. So here's, a limited approach is an approach limit at a distance from an exposed, the critical word here, exposed, energized electrical conductor or circuit part within which a shock hazard exists. And then the other part, the restricted approach is an approach limit at a distance from an exposed energized electrical conductor or circuit part within which there is an increased likelihood of an electric shock. It's almost like you're next to it. So any movement, inadvertent, or if there's like an arc, you can be exposed to shock, right? And of course, the arc flash boundary is where an arc flash exists. And the next page kind of show you what the arc flash boundary is. The arc flash boundary, and this is just the label. And this is directly taken from the NFV 70 book that gives you, depending on the voltage level, it's fixed, the limited approach and restricted approach. So the higher the voltage level, the higher the limited approach and the restricted approach boundary. And that's just to talk about general use. And so we put your label on one H vertical section. So if you notice one here, one there, every one of those has a label. Yep. they're all there, right? And
There it is right there, yep.
so the value in the study and on the label show the incident energy expected when worker exposed to energized conductor or parts. There's no calculation that we can do when the cover are in place, door, close, etc. The sign of arc flash is not that advanced. So I think that's about it for my portion. You think, well, I'm not going to be working on this in here, but if you have electricians or come out here and do work, you need to provide them this information. So that's why he has this detail, has that information on what he needs to wear to protect himself. And so if this is the fault current is too high and you say danger prohibited, to ensure that it can be worked on safely, you got to make sure you de-energize the switchboard. I don't think, before
Before you even open it up.
Yeah, before you even open. I remember back then, I've been doing this for 20-some odd years, 25 years, and there's no problem opening this and taking a look and sticking your head in there. We don't do that anymore, right? So there's things I did in the past that
But you're still here.
I'm still here, and it's like, I can't believe I did all that. So that's my portion.
Yeah.
Okay.
Let's see if there's any questions.
Yeah, do you have any questions, anything?
So all that information that a contractor would need is gonna be right there.
Yeah.
That stuff isn't always readily available.
Exactly, and it's in that study also, so I believe.
And these are on every panel board,
Yep.
so they're on the individual panel boards too, if you open these up, these stickers are everywhere, right?
It should be. I don't
They
see it on
will
the.
be.
Okay.
We can go to a flexible room if you want.
Yeah, well,
They need to be not on the inside, they normally get placed on the outside.
before you open the cover?
Yeah, because again,
Okay, this was on the inside.
it's got on the inside, which is fine, that's a.
Oh,
very
perfect. Here, I'll
well
get this.
But typically you put it on the front end, so that way,
At least some key.
And if you have electrical contractor comes to do any work, you want to make sure this gets updated. If you're adding a panel, add it to the drawing. Because over time,
Oh, yeah.
it gets
So-
messy.
One other thing to add, since we're kind of talking about arc flash and one lines, as he mentioned before, if there are any changes taking place, you have to update the documents, right? But also what's very important is on an arc flash, for instance, what you have to keep in mind, because they turn it over to you, but NFPA requires this arc flash study be updated every 5 years to still be in compliance. So that's something to keep in mind. If it's not updated, you could be fined if something happens, that kind of stuff, because of you're not keeping the records current or under, that kind of thing. So same thing with these records and stuff. If you have electricians or even if you have us come on site and they're not accurate, you are responsible for providing all accurate documents. That's why it's the O&M manuals, one lines are really important. We can move over to the switchboard. We'll continue a little bit with these, with the maintenance on the switchboards and how to operate switchboards. Now, technically, because that label is prohibited, you're not supposed to do anything with the switchboard while it's energized. So to be on the safe side, if you're looking at doing anything with the switchboard, you have to get the utility to kill the switchboard. And then you can continue on doing everything you need to do. So that's why those labels become very important to understand and what you can and can't do with the equipment energized, right? Now, normally when it comes to maintenance or any work we do, period, we as the manufacturer recommend that you don't do any work, regardless of what those arc flash labels will tell you. Don't do anything with the equipment energized. So, for instance, our safety practices, you call us out to help you do maintenance or things like that, testing, we will not touch it unless it's completely de-energized. Most contractors, and Prairie's not here to mention, but most contractors have the same policies these days. You hardly find any contractor to do anything with the equipment energized. As the safety practices have really been getting a little more, so when it comes to operating a switchboard, again, when you get in, now, if you have to get in and do maintenance, you have to kill power. On the maintenance side, we recommend as a manufacturer you do maintenance once a year, some form of maintenance. Most customers don't do it. That's up to you. Once the switchboard comes out of warranty, it's really your responsibility. It's your product, right? But we do recommend make sure you have a good operational and reliability is do maintenance once a year. And what that means, you open it up, you go through it, you check every termination, connection. You look at debris, you clean the debris in there as well. Because, as you can see here, being an open switchboard, now in this particular case, it's very enclosed room, ventilated. You don't have a lot of debris flying in here, but you do come across, and that's why we recommend once a year cleaning it up, because we cover all the environments that these switchboards are operated in. A lot of customers operate these switchboards in a very heavy commercial industrial facilities where there's a lot of debris going in, right? You could have cement blowing in there, or you can have all kinds of things, which is very conductive. If it gets on the insulators, and you can create over time tracking and short face-to-face. I've seen a lot of those switchboards, and it's scary, but they've been operating for a long time under those conditions. Now, again, to have a good maintained switchboards, once a year you can develop your own program, maintenance program, and what's the frequency of you going in and maintaining it. But again, we maintain you once a year. You go in, you inspect it, you clean it, you torque it, and you test it. Now, in the past, because the electronics were not as advanced as they are today, primary injection, if you wanted to test the breakers, was the way to go. Okay, now all of these breakers that you have here, I didn't see any thermomagnetics except 2, 3, a couple of them. The rest of the breakers, you can see like these here, this here, you can accomplish all that by secondary injection, which doesn't put a lot of stress on the breakers either. So in our instruction bulletin now, you will see that we recommend doing a quick secondary injection to test electronics, part of that maintenance program. If you ever want to put together a maintenance program, let us know. I'll come out, I can work with you, I can help you write that maintenance program. We have, we can support in that direction. 5-year warranty on them. The only downside to that is you have to call in every time, and you have to wait until they ship you one. So,
having 1 or 2 on hand might be a bad idea.
I always recommend, yes, they have warranties, longer warranties than standard on a switchboard. The standard warranty on a switchboard is 18 months. These have these are the only product we carry that I think have a 5-year warranty. Unless, and I mentioned that just in passing, but if we would have done startup on this, we normally add another a year or 2 warranty on top of the standard warranty. But this only includes product, it doesn't include labor. So if a module goes out, you have to call in through Prairie or whoever you purchase the equipment. They'll call into our distributor. They'll get you another, they'll ship you one. You have to take that one and ship it back, and that's how the warranty works. It doesn't cover labor, it only covers the product. So, I mean, again, having a couple of them in hand as a spare in here in the room may be a good idea, just so you don't have to wait. And your system is protected, right?
So even if it's taken a hit, it's still green, probably a good idea to replace it maybe?
No.
Necessarily.
I've seen some of these take a lot of hits. Again, it depends on the magnitude of the hit, right? And how many hits too, right? I mean, obviously if you take 20, 30, 40 hits, eventually that thing will go, right? So you always look at the counter to see how many hits it took. If it starts taking a lot of hits, even though it's green, first you may want to question the utility. You may want to look into, why is it taking so many hits, right? Because obviously, if you take so many hits and your module goes out and not protected, it takes another hit, then you're vulnerable on your system.
Is that resettable? Counter?
No. This is pretty much set, right? So it's, again, it's...
I mean, even if you put all 3 new ones in,
No.
what counter set it?
You gotta remember that number, I guess, when you replace
Yeah.
them.
Sure.
Yeah, with this Sharpie on the side. And that's a silence button, it looks like, and those are test buttons.
Well, it's push to test, right? And it's silence. Now, these have context in there. If you want to take this to your building management system, you can for the alarm, and it gives you some status, right? But it's really basic. It doesn't give you a whole lot, but it does have an alarm on it. It has a contact, right, that it gives you an alarm. If one of the phase takes a hit, goes out, you get that alarm if you want to go in that direction. will save you coming in here every couple of months to look at it, right? Because you're already monitoring it. But you either have that or, like I said, it's a good idea to come in here every so often and check those just to make sure it's still protected. Anything else on the TVSS? Okay. On the breakers, this breakers are NW breaker. To operate this breaker, so here's the settings. Assuming it's all set, you don't have to touch this, right? You have a couple of LEDs up here, but in order to operate the breaker, you have to pull this. So you have the open close button, okay? If the breaker's in, and then you have the charged flag. What you have to do is crank this up until this is charged, and then you can close the breaker. If we try to close the breaker and it doesn't close, that means it's not charged. So you have to look here. Right now, is this charged? When it's charged, that flag will turn to us. I believe it's yellow. So obviously, if it's open, if it's closed, you open the breaker. If it's open, if it's charged, you can close it. If not, charge the breaker and then close it, okay? Now, that's only mechanically if you want to operate that breaker mechanically, but even if it trips under fault. But if it trips under a fault, that button right there will pop out.
Like a GFI outlet.
And you cannot reclose that breaker until you reset that button, okay? That's nothing but a safety feature. Because if that breaker trips under fault, it wants you to think before you rush into here and put that breaker right back on the fault. And that's how these are designed for that reason, right? If it trips because of a fault, then it wants you to think. That's it. But again, if that's popped out, you cannot close the breaker until that's pushed back in. And I had multiple times customers calling me direct and panicking because they can't reset the breaker, And did you push the red button? No, what red button? You know.
I was gonna say, what red button?
Yeah. So, so that's that. That's the reset button. That's all it is. Now, if a breaker trips, if this breaker ever trips, one of these LEDs will come on. And this is why it's very important you kind of remember this. Because if you call Schneider to help you kind of diagnose the issue, this is one of the first things I'll ask you. What did it trip on? If you reset the breaker, then the LED goes away and we'll have to wait for the next event. But this right here tells you that you tripped on long time, overload. This right here is short time or instantaneous. You had a spike of current in there right? Ground fault. And that AP light is an indication there might be something wrong internally of the tripping unit of the breaker. If the AP light comes on, that's not good. Because it's either the tripping unit needs to be replaced or in some cases, very rare cases, the breaker might have to be replaced. We always try to set with the tripping unit first, but I've had it in there if water or moisture got inside the breaker. I've had it one where they put the switchboard outside in the middle when it's raining and the electricians were floated and trying to get over it to pull cables and water was all over the breaker. And you wouldn't think of it, but it got inside of it. And then what it's doing is start rusting the terminations and wires in there, and that thing gets confused. And it won't hold. In most cases when that happens, it doesn't hold past 40 or 50% because it doesn't know what's taking place. And then the AP light will come on. Any questions over this breaker here? Okay. This is DRMS. This is the arc flash reduction. It kind of goes hand in hand, it kind of goes what he was describing about arc flash. In this particular case, neither one of them are working, so we may want to ask Prairie when he comes back in. There's a disconnect back here that normally, from ours, it comes in the off position, and most of the time that fixes it, but if not, then this is an issue. Now, the way this is supposed to work, this is always in the off position, and I'm going to leave him in the off position. The reason now, when you turn them on, this right here comes blue, and then this right here will tell you it's in ERMS mode, okay? Now, what that does, and what's intended by code, any breaker that's 1200 amps and above has to have a means of mitigating the arc flash. In a study that Lee had referenced, you should have two tables. One table is when you operate under normal conditions, which means this is in the off position. And it's not recommended, it has to be operated in the off position. And then those labels and everything apply. But in the studies, there should be a label when this thing is in the on position. What that means, all the settings that are in here, it takes them down to the lowest possible settings, which means that breaker trips faster, reduces your arc flash downstream. Now, to some degree, if you want to get into that panel board over there, right, you can come over here, put this in the on position, and it reduces your arc flash at that panel. Although we don't recommend working on anything that's energized. But that's what the intent of it is, to reduce arc flash downstream. If you're, for whatever reason, if you're looking at reducing that level, but it's always recommended to be. So when you're done with the work and you don't need it, you always put it back in the off position, and it needs to operate in the off position.
That reduces the ampacity also?
Not the ampacity, it's the arc flash.
Okay.
It reduces it. Am I correct on that?
Yeah, let me take a look at the, right here. I'll show you the.
It doesn't reduce the ampacity because, again, remember when I said long time dictates the ampacity of the breaker? It reduces short time instantaneous. It reduces the magnitude of the fault current that this breaker will allow it to go through. So if this breaker was set as 10 times instantaneous, that's a 3,000 amp breaker. That means that on instantaneous, it's letting 30,000 amps to go through before this breaker trips, okay? Which, again, when you have high arc flashes downstream. You put this in the on position, it reduces the instantaneous to its lowest level. I think it's either 2 or 2.5 of 3,000. So it's 6,000 amps. So breaker trips at 6,000, not at 30,000 on instantaneous. Therefore, it's reducing your magnitude downstream.
Down the short or something like that, the arc flash won't be as big. It'll trip out sooner.
It trips sooner, yes. Go ahead.
Yeah, the arc flash, the incident energy is a function of time and available fault current. So if you reduce the available fault current, you reduce the time, the incident energy will go down. That's the intent of the ER.
Okay, that makes sense.
So you have to work on something high.
No,
You
no.
shouldn't supposed to.
No. Do not.
Yeah, so here's what it does. So here's the characteristic, for example, of that breaker.
Mm-hmm.
So in the off position, it's like this, right? So here's your short time, here's your long time, here's your short time, and then here's your instantaneous. So what that does, when it's in the off position, this is the way it's gonna operate. So if you turn into the on positions, this right here drops down to like right here.
To the left.
Yeah, it's far. So if you had a fault right here, now it's gonna trip instantaneously. Whereas if you left it in normal positions here, if there was a fault here, it would take longer to trip instead of waiting it down here, right? So that's the intent of the ERMS switch there.
And in the study, there should be a table specific for all the, so you'll have a couple of tables. One of them is the arc flash based on the normal operating procedures. But there's another table is when you put this on, there's a new arc flash calculation when you operate the equipment with this on. But again, like I said, this is not only intended to do if you're needed, but it's off is what the intention of normal operation mode, right? Now, if you have electricians or yourselves and you need to reference that table and say, well, if I put this in the on position, that arc flash label, pretty much you have to reference the table that talks about when this is in the on position. If not, you reference the table when this is in the normal position, right, off position. So, but it also changes, obviously not on this, but downstream.
It affects everything downstream.
Everything downstream, yes. Everything downstream from here. Now, like I said, by code, any 1200 amp break, so if this is a 3000 and you had a 1200 amp feeder over here, then that feeder would also require to have one of these by code. Because any breaker that's 1200 amps and above require arc flash, or I should say, is it arc flash or what is it? Reduction. Some kind of mitigation and reduction of arc flash, right? And like I said, you may want to check with Perry to turn the breaker
How do
on.
you know that's not active right now? Don't we see the switch? How do you know it's not active?
It's not lighting
The
up.
light's not on.
So this comes blue. There's an LED in here,
Oh,
it turns blue.
It'll turn blue, you can't
I miss it.
Right at the top of it here will say ERMS.
Oh, it'll tell you there too.
Yeah, so you know its ERMS is on.
Oh, okay.
Now, there could be a possibility this turns blue, but it doesn't come on. So you have to look at both in order to make sure it's operating correctly.
You switch, but it's a blue, bright blue light.
Yeah, you'll see it, you'll see it. When it's on, you'll see it. You can walk through the door,
No
you'll
doubt.
see it, yeah. Any questions around TVSS, breaker, ERMS?
Makes sense.
Okay. These are, in difference to this breaker, you don't have to charge the mechanism on, off. But if the breaker trips, the handle will be in the, sometimes it's kind of misleading in a way. It will trip, it will be just half an inch or something lower from, or off to where it's from right now.
See that little gap in between?
Yes, yes. And you do have to reset it before you turn it back on. Now, so that resetting, it's almost the same concept as this red button over here. Because if you have to reset the breaker, that tells you that it tripped on something, right? It's not you operating the breaker on and off, it tripped on something. So then having to reset is again, part of the reason makes you think, why did that breaker trip in the first place? And should I look at the system before I throw it back into a fault again, right? Just keep that in mind. This right here has the same port as these breakers here. So this is not necessarily for you unless you want to do your own maintenance. We do have test kits that some customers can purchase, and you can, through these ports right here, or the one behind this cover here, you can take this, what we do, take the secondary injection test set, hook up to these breakers, and we can test these breakers electronically. The difference is if you do a primary injection, you have to bring in big test sets, that kind of thing. But that's what these ports are. You have standard trip units. This one is an ammeter, at least a P trip unit. So this one displays, these are pretty much standard. These breakers are really nothing more, nothing very specific to them, on and off. Again, making sure the settings were set correctly, just for operational, make sure that's operating correctly, not only in terms of arc flash like we're talking about, but also coordination, right, with the breakers downstream. And there really is, once these are set, when everything is set, you don't have to worry about them unless you have to test them, or unless somehow you have to replace one at some point. But if you need to order another breaker, what you have to look at is these part numbers, right? And what you have to look at is these ratings over here. As he said before, if you have to replace a breaker, so let's say I've seen customers every now and then, they want to upside the load or something, so you go replace it from 600 to 800, right? Which is fine as long as you order the same AIC breaker. For arc, again, for in case there's an event going through that breaker. That's one of the most important things is the ampacities, obviously, the type of trip unit that you need, but also making sure that that breaker is rated to withstand the fault current that's going through. These are rated at 65 kA at 480. So that's how they were ordered based on the study that was done. And basically, any breaker that you plug in here has to be 65 kA rated. Now, you find out that these are I-line style breakers. You can take this breaker from here and plug it into that panel, okay? Which is fine, because this breaker is higher fault current rated than that panel. But if you take a breaker from here, from the panel, which is the same breaker, it could be the same L-frame breaker, you take it from there and you plug it in here, you may create an issue for yourself because those breakers are probably rated at a lower level. Those could be at 35 kA at 480. These are 65 kA at 480. You can take this one and plug it in there because it'll be way above its withstanding rating, but you cannot take a breaker from there. Although it's the same breaker, the only difference is that KA rating, that rating of a breaker itself. So something to keep in mind if you're ever on swap breakers or things like that while you're operating a switchboard is making sure that you plug the right breaker in the right switchboard so you don't create issues. But these breakers, again, right here are very straightforward, nothing to them, on and off, or in case they trip, and that's really about it, because in most cases, you guys won't touch them unless you get your own test set. It's usually tourists or us coming out to do maintenance on that program. Any questions about the breakers themselves?
Trip the test?
Yes,
I could pop that breaker?
you can.
Not
It's,
that I
it's
want
not,
to,
it's
but-
not necessarily a really good way to test that breaker, right?
I just happened to notice it wasn't very buttons, I thought it was whole flesh, I'm like, trip the test?
You can, that's to see if it's mechanism. So it's not a push to test on a trip unit, it's to push the test on the mechanism.
Okay.
Mechanical, yes.
Testing it, yeah.
But that's a good question, I missed that. It's a push to test mechanically, it's not a push to test. That tells you that the breaker still opens mechanically, right? That's really it. It doesn't test the electronic part of it, the true protection part of the breaker. Now, when you do maintenance, is it good to always do a trip by push to test? Absolutely. But at the same time, when you do maintenance, when they'll test this breaker, they'll also trip the breaker mechanically as well with the trip unit, with the test set in order to validate the same function, right?
Oh, yeah.
So that push to test is hardly used
Right.
because you can check that function when you test the breaker. On these test sets, you can say test the breaker without tripping or test the breaker with tripping. We always test it with tripping to check that mechanical function.
Sure.
And I don't see that you have anything else, so that kind of covers the maintenance on it. And really, when you go downstream, right? Obviously, this is a big switchboard, ion panel boards, same concept, right? If you look at maintenance, check torque, check connections. A lot of the, I don't know if you develop yourself an IR program, but one of the most events that take place with switchboards, panel boards, and so on, is the loose connections over time, right? So that's why the maintenance is intended to check connections. A lot of customers will put in, so in this particular case, we have IR windows that we can put. We replace this cover with the cover that has got an embedded IR window from top to bottom. You can open it up, do your infrared, and you check all the connections.
Also thermal imaging.
All on the cables, yes. Well, when I say cables, it's the connections to every breaker, right?
Yeah.
The only thing you don't see is the connections in the back. So you can, if you put IR windows, right? Same thing on those. Now, I'm gonna go a little bit, so we have those. If you're interested, if you have an IR program, especially since this one is prohibited, and if you have an IR program, you can't take covers off. Even if you're suited up, you can't take these covers off in order to do the infrared. So that's why those covers that we have may be coming to very valuable to you, because you don't have to expose you or the thermographer to the switch, because they cannot do thermography anyway. Now, because of these kinds of incident levels, I'm going to go a little bit into the maintenance procedure, something that helps. In addition to these covers, we also have what we call the asset advisor. We can put heat sensors on the connections you can't get to, and they give you 24 hours information on the connection, on those connections, right? So there's different different things. If you need support on setting up maintenance cycles, what to do in maintenance, some of the things that can help you maintain a switchboard, like infrared programs, let us know. We can work with you on that. But other than that, I mean, like I said, on the switchboards, transformers, very straightforward. Most people don't touch them, but we still recommend to do. So yearly maintenance, check connections, and you can do a measure test and a ratio test on those transformers. But same thing on those transformers, we have rectangular IR windows. Again, if you're looking at putting a program together, those windows may save you, especially on this one, because you cannot take it down, period. But other than that, most of it is it's a very standard equipment when it comes to transformers and panels. Most of that is connections if you're looking at doing maintenance. But any other questions about the switchboard itself? This switchboard is exactly the same as this one. So everything that we covered here, it pretty much applies here. Same products, the TVSS, and that one doesn't work either. So the other thing to mention is have them check that breaker. But anything else that we can cover for you? If you have,
So
the feed's coming in from outside somewhere, right? From the
Yes.
street utility? Do we know where that's at?
I don't know, that's something you wanna ask Prairie, because they're the ones who installed it, right? I don't know,
Pads out there, less than walked out there by the generator.
but it looks like all your feeds come from underground, and everything going out is underground, because I don't see anything coming from the top.
I said, I thought it was, I walked out there by the generator.
There should be two of them. Right there.
Ah, there they are, right there, both of them.
Oh, there you go. You can go out there somewhere.
Yeah.
You don't have to walk past
There we go. One for each, right?
Yep, should be.
1,500.
Are those utility rooms?
Yeah, yeah,
No.
those,
No, you don't. That-
We own everything from this meter this way. Everything from this meter that way and all that.
Oh, there's, on this switchboard, I just noticed, you have a fire pump, so you obviously have a fire pump in the building, right? The reason, this fire pump is before this breaker, so it's not protected by anything.
No,
It's designed on
right from the
purpose,
street.
it's designed on purpose to run until it burns down in case of a fire. So that's why it's not, it's here.
You
So,
can't turn the fire pump off.
no,
Because I noticed when they did that.
It doesn't have a
When they
disconnect.
first did it heel, it goes, we have more than 2 stories. They did it heel for the first time, and they'll explain that to us. Basically, like I said, it comes right from the street. You would have to kill it out there at the.
Doesn't have a disconnect for maintenance
What?
at the fire pump itself?
There might be a shut off there,
Yeah.
but you can't kill the power to it unless you disconnect it at the guy's box.
Just the one?
Like I said,
Yeah,
it's
that
meant
one
to
doesn't have
pump
it.
until the building burns down, or the pump.
well, I
burns
mean,
down.
that's in case of a fire, and there's some kind of, fire can create faults that breaker can trip. Now, the other thing too, just really quick, it's a good thing we talked about that. This breaker has a ground fault. None of those breakers do. If you ever have a ground fault, doesn't matter where it says, this breaker will trip everything. Something else to keep in mind, right? So when we talked about the coordination is between this breaker to these breakers, from these breakers to the breakers downstream, and that's long time, short time, instantaneous. This is the only breaker that has the ground fault protection. I've heard of people having a cord or something going over that cord and tripping off.
We have one
Upstream.
We have one at Fisher's Landing like that, and then every once in a while, it does a nuisance trip.
Oh, yeah.
So just keep some, I mean, I'm just probably overkilling it by saying a cord or something, but you could have an issue at a panel, who knows where down there. And when it comes to ground fault, this is the only place that may take place.
hospital requires 2 levels of ground fault, so your main and all the feeder that's in the switchboard. So they have 2 levels, so if there's a fault downstream, the feeder would trip, so you coordinate that. That's the NEC code requirement for hospital. But it's not required for like a school or anybody else, only for critical facility.
Right.
in the
That way
hospital.
it'll lose everything.
Yeah, exactly. You're on the operating room table, something.
So if we got half the school without power, we probably know it's right here.
Well, what I suggest, so here's the thing. These are set, being at 3,000 amp is probably set somewhere like, depends on what the setting is. 1,200 is the highest, but you can go down to like 300, 400 on a ground fault. So it depends on where it's set. 400 amps, 500 amps, that's when it trips it off, right? It could go up to 1,200, like you said. Now, the breakers downstream, let's say you have a 40 amp, 50 amp breakers downstream, thermomagnetics, they have a very long timing. Sometimes they can count for like 10 seconds before it trips. This one, it reaches that level, it's pretty quick. So it could be that you have a ground fault way downstream, created enough of a magnitude of a fault to trip this breaker, right? Now, kind of a pointer, I would say, if that happens, what I tell customers to do is, because trust me, I've been through some of the concerning, I say, customer under stress to get the building back online and they don't know what tripped it, that kind of thing. You turn all these feeders off, turn this one on, start one by one. Process of elimination, right?
Yep.
So if the LED comes on ground fault, that's something you may want to think about and then try to figure out where the feeder
It's
is.
the same thing at Fisher's Landing. Like I said, we had to turn everything off downstream, turn it back on, and then one at a time, and then wait 2 minutes, and then eventually, boom, oh, that's the one.
Well, at least that way you know, you can turn the rest of it off and keep that breaker off until you find the ground fault, you fix it. But just want to mention that in case for operational procedures, right? If that happens, that could create some headaches, especially if it's in the middle of the school, try to get everything back online, that kind of thing. But keep in mind, you run out here, you see that ground fault that's on, you tripped on ground fault, that's when you start the process of elimination and figure out and try to isolate it.
But we got generator firing up and everything else happening.
Well, there's
Yeah,
different,
If your generator fires up and it starts powering this, it's gonna trip again, even if you close it. Doesn't matter, right?
but I don't see, do you have a generator backfeeding it? I don't see, so you must have an ATS.
Generator, so what's that?
Not backfeeding this, you have a generator backfeeds the, a fuel emergency pump.
Ah, so you have
You
to,
got an ATS downstream.
so you don't have to,
Downstream.
yeah. So you don't have to worry about the generator tripping this one, but
Yeah.
again, this LEDs will
That's
get,
good because it'll tell you, like you said, it'll tell you ground fault, so then you know how to proceed from there. Instead of guessing, when it happened at Fisher's Landing, we had no idea why the breaker was tripping, and troubleshooting was phenomenally a pain in the butt.
There's no generator there.
Where you come here, go ground fault, then you can say,
Yeah.
okay, start doing this way.
yep.
It's very handy to have that.
And then you can use the wall lines for process of elimination to what's on that feeder and then start
Yeah.
going downstream to try to figure it out, right? But that's, in case that happens, that's because, you know, you could sit here and not know what to do and panic, right? 'Cause sometimes the pressure comes in, especially if it's in the middle of the school.
Especially when the school's screaming at you.
Yeah, yeah. We've been there, right, and it's what it is. But yeah, those LEDs, in case something, those LEDs will start the diagnostic process if it's ground fault process of elimination.
At least it's a clue.
Yeah.
Cool. Wow.
Anything else that I can cover for you guys?
I think so, that's pretty good.
I think that's about it. Cool.
As we close, you'll get your operation manuals. If you have any questions over those, feel free to get a hold of us. We'll help you out. I can come back out. We can go through those operation manuals. I can help support that maintenance program going forward. If you need any parts or anything like that, feel free to get a hold of us. We'll support you.
Wonderful.
I'm here local. He's out of Seattle, but I'm here, and I live in Portland, so I'm a local rep.
Okay.
There's a Schneider, do you have a card?
I have him in the car. I didn't bring him with me, but I can go and come back, give him to you guys.
We can Google it.
Well, no, if you need a card, let's get you. Our 800 number or 888 number is really not easy to navigate through.
And then everyone's in a boiling room that does a nuisance
Oh,
control.
yeah.
So just keep some, I mean, I'm just probably overkilling it by saying a cord or something, but you could have an issue at a panel, who knows where down there. When it comes to ground fault, this is the only place that may take place.
Hospital requires 2 levels of ground fault, so your main and all the feeder that's in the switchboard. So they have 2 levels, so if there's a fault downstream, the feeder would trip, so you coordinate that. That's the NEC code requirement for hospital. But it's not required for like a school or anybody else, only for critical facility.
Right.
at the
That way they
hospital.
don't lose everything.
Yeah, exactly. You're on the operating room table or something.
So if we got half the school without power, we probably know it's right here.
Well, what I suggest, so here's the thing. These are set, being at 3,000 amp, is probably set somewhere like, depends on what the setting is. 1,200 is the highest, but you can go down to like 300, 400 on the ground fault. So it depends on where it's set. 400 amps, 500 amps, that's when it trips it off, right? It could go up to 1,200, like you said. Now, the breakers downstream, let's say you have a 40 amp, 50 amp breakers downstream, thermomagnetics, they have a very long timing. Sometimes they can count for like 10 seconds before he trips. This one reaches that level, it's pretty quick. So it could be that you have a ground fault way downstream, created enough of a magnitude of a fault to trip this breaker, right? Now, kind of a pointer, I would say, if that happens, what I tell customers to do is, because trust me, I've been through some of the concerning, I say, customer under stress to get the building back online and they don't know what tripped it, that kind of thing. You turn all these feeders off, turn this one on, start one by one. Process of elimination, right?
Yep.
So if this one, if the LED comes on ground fault, that's something you may want to think about, and then try to figure out where the feeder
It's
is.
the same thing at Fisher's Landing, like I said, we had to turn everything off downstream, turn it back on, and then one at a time, and then wait 2 minutes, and then eventually, boom, oh, that's the one.
Well, at least that way you can turn the rest of it off and keep that breaker off until you find the ground fault, you fix it. But just want to mention that in case for operational procedures, right? If that happens, that could create some headaches, especially if it's in the middle of the school, try to get everything back online, that kind of thing. But keep in mind, you run out here, you see that ground fault that's on, you tripped on ground fault, that's when you start the process of elimination and figure out and try to isolate it.
But we got generator firing up and everything else happening.
Well, there's
Yeah,
different,
If your generator fires up and it starts powering this, it's gonna trip again, even if you close it. Doesn't matter, right?
but I don't see, do you have a generator backfeeding it? I don't, so you must have an
You say you have a
ATS.
generator, so what's that mean?
Not backfeeding this, you have a generator that backfeeds the, a fuel emergency panel.
Ah, so you have
You
to,
got an ATS downstream.
so you don't have to,
That's downstream.
Yeah.
yeah. So you don't have to worry about the generator tripping this one, but
Yeah.
again, this LEDs will
That's
get,
good because it'll tell you, like you said, it'll tell you ground fault, so then you know how to proceed from there. Instead of guessing, when it happened at Fisher's Landing, we had no idea why the breaker was tripping, and troubleshooting was phenomenally a pain in the butt.
There's no generator.
Where you come here, go ground fault, then you can say,
Yeah.
okay, start doing the this way.
yep.
Very handy to have that.
And then you can use the wall lines for process of elimination to what's on that feeder and then start
Yeah.
going downstream to try to figure it out, right? But that's, in case that happens, that's because, you could sit here and not know what to do and panic, right? 'Cause sometimes the pressure comes in, especially if it's in the middle of the school.
Especially when the school's screaming at you.
Yeah, yeah. We've been there, right, and that's what it is. But yeah, those LEDs, in case those LEDs will start the diagnostic process if it's ground fault, process of elimination.
At least it's a clue.
Yeah.
Cool. Wow.
Anything else that I can cover for you guys?
I think so, that's pretty good.
I think that's about it. Cool.
As we close, you'll get your operation manuals. If you have any questions over those, feel free to get a hold of us. We'll help you out. I can come back out. We can go through those operation manuals. I can help support that maintenance program going forward. If you need any parts or anything like that, feel free to get a hold of us. We'll support you.
Wonderful.
I'm here local. He's out of Seattle, but I'm here, and I live in Portland, so I'm a local rep.
Okay.